In this lesson, we want to be able to say that I can solve systems of linear inequalities by graphing. And our second one that we want to be able to say is that I can determine the coordinates of the vertices of a region formed by graph and of a system of inequalities. Just to remind ourselves, let's remind ourselves what a system of inequality is. A system of inequality is just like a system of equation, where we have more than one inequality happening. So we could have, let's say we have y is bigger than or equal to 2x plus 1. That's not a system because we only have one set of inequalities. We could also make another inequality of y is less than or equal to 5x minus by 2. Now since we have two inequalities, this is now a system. We can have 3 inequalities in here. We could have 4 inequalities in here. We can have 5 inequalities. It does not matter how many you have as long as you have at least 2. That is what makes it a system of inequalities because we have several of them that we are going to be comparing. Let's look at an example. Here's a system of inequalities. It's not a system of linear inequalities because both of them are not linear equations. This top equation is an absolute value equation. In absolute values, if you want to graph an absolute value equation, it's always either going to be a V facing upwards or a V facing downwards. Either one or the other. So main key things that we need to know about this V is where is the point at which it turns? Where is that vertex in which it turns? And how you know where it turns depends on what we're adding on the inside or what we're subtracting or adding on the outside. So for example, the one that we currently have, if we have something being added or subtracted on the inside, that is going to affect us moving right and left. So for example, if we have, let's say, x with a plus a, either plus a or minus a in the absolute value, this controls moving it right or left. If it is positive, we are going to move it to the left. So let me do this. We're going to move it to the left. If it's negative, we're going to move it to the right. If we have it on the outside, let's say we have absolute value of x, and let's say we either plus or minus a b value. This is going to be the vertical line. If it's positive, this one actually does what is expected. We're going to go up. If it's negative, we are going to be going down. That's how you can tell. Also, if it is a negative on the outside of the absolute value, that's whenever you know it's facing downwards. Whenever it is positive on the outside, that's when we know it's facing upwards. So keep all these things in mind as we graph this. So for our system of inequality, we have an x plus 1. That's a plus, which means we are going to be going to the left by 1. So we're going to be at negative 1. So we're going to go over to negative 1. And we are going to go down, because we're minusing 2 on the outside. We're going to be going down by 2. So our vertex of this absolute value is at negative 1, negative 2. That is a point whenever it stops going down and starts going up. And this absolute value is positive, so it is going to go down and then bounce up. Now we have to just plug in a few points. Just plug in 2 points that are around this vertex. So let's plug in let's say negative 2, and let's plug in 0 for the x. If x was negative 2, this would end up being negative 2 plus 1, which would be negative 1. Absolute value of negative 1 is positive 1. Then we have 1 minus by 2, which is going to give us negative 1. So at negative 2, we are at negative 1. If we are at 0, this would be 0 plus 1, which is 1. So let's go ahead and plug in 0. 0 plus 1 is 1. Absolute value of 1 is 1 minus by 2. Again, gives us negative 1. And that's expected because these x values that we chose are just 1 away from that turning point. So our absolute value looks something along this lines. By the way, we can expect our absolute value to look something along that lines because we don't have something multiplying on the outside of the absolute value. So it's going to be that slope of either positive 1 or the slope of negative 1. So keep that in mind. All absolute values are going to act the same way. We are going to have more examples of this a little bit farther in the video. Okay, so now let's figure out which side to shade. So I'm going to erase some of this stuff just to figure out what side we want to shade at. Okay, let me just finish erasing. There we go. So to figure out which side to shade, do it the same thing like we did a regular inequality. Choose a point. Either a point on the inside or a point on the outside. Let's just choose, we know 0, 0 is a point that is inside the absolute value. So let's just choose that point. If x were 0 and y is 0, let's see if this is true. So absolute value of 0 plus 1 minus by 2. This would be 0 is greater than or equal to absolute value of 1 minus by 2, which is 0 is greater than or equal to 1 minus by 2, which is negative 1. Is that true? Well, yeah, that's true. So we're going to shade on the inside of this absolute value. Also, another thing to keep in mind, is it dashed or a solid line? It's solid because of this line underneath. Because of that solid line underneath, meaning it can be equal, our answer is going to be a solid line there. Well, that's how you graph an absolute value. Now let's graph the other one. The other one's super easy. It's linear. So we have our intercept, which is at 1. I'm going to use green for this one. So intercept at 1. Slope is 2, so we rise by 2, run by 1. Rise by 2, run by 1. So our slope, our graph, is going to look something like this. And don't get too confused by all the different lines that we have here. Let me just do that. So that is the graph of the other one. The issue is it solid or will it be dashed? Well, because it doesn't have the equal to underneath, it's going to end up to be dashed. So let's go ahead and just change that to be a dashed line. I'm going to leave the green line there so I can just follow along with it. So this is going to be our other line. And last thing that we need to do is figure out which side to shade. Well, let's just choose a point. Let's choose, well, 0, 0 isn't on the line. 0, 0 is right here. So let's choose 0, 0. 0 is less than 0 plus 1. So 0 is less than 1. That is true. So we are going to end up shading down this way towards 0, 0. Okay, I know that this is getting to be a mess. Let's actually figure out what the actual answer is. For it to be an answer to a system of inequalities, it has to be shaded in both of the regions. So I'm going to actually highlight the answer. The answer to this is going to be this piece that has both the shaded of the blue and the shaded of the pink. So this is where the answer lies. Nowhere else, just between there. The only solutions to this system of inequalities is a spot that is in both of the shaded regions. So that would be the solution to this. You could regraph it to be just that section right there. Let's do another example. Solve the system of inequalities. Okay, we have another absolute value. Remember I said that if it was negative on the outside, we are going to have it facing downwards. Remember that I also said that if it does not have a number on the outside of the absolute value, because there's not a number out here, the slope is going to be a nice 1. So that's going to be nice for actually graphing it. Then we check the inside. We don't have it added or subtracted by anything, so this point is not being moved anywhere. It's actually going to stay at 0, 0. We don't add or subtract anything on the inside. We don't add or subtract anything on the outside. Now our issue is we have this multiplication of 3. That is going to change our slope so that our slope is not just a nice 1-to-1 type thing. It's not going to be a nice 1 slope because of that multiplication on the inside. So let's actually figure out how it's going to rise, how it's going to run. So let's pick a few points. Let's choose an x. Let's choose a y. Let's say x was, we can't choose 0 because we already have the point being 0, 0. That's where the vertex is. That's where it hits and goes back. It's actually going to be going up, hit that vertex, and then go back down. So let's choose -1 and 1. Good points to choose. We already know at 0, we're at 0. -1. -1 times 3 is -3. Absolute value of -3 is +3, but we have negative outside, so that's going to be a -3. Because this is the same distance, because -1 is the same distance as +1, we would expect the +1 to also be at 3. So at 0, at -3. At -1, we are at -3. That's our other point. At +1, we should be at -3 as well. We could check that as well. We could plug in 1. 1 times 3 is 3. Absolute value is 3. Negative on the outside, so it's being negative. So let's go ahead and graph this. We just need those 2 points. This is our graph of our absolute value. Dashed or solid. It's going to be dashed because there's no line underneath. So we need to change this to be a dashed line. I'm actually going to do a different color than pink. Let's do blue. Dashed line. Because it cannot be equal to these values. Then let's figure out where we shade. For figuring out where we shade, what we are going to end up doing is just pick a random point, either on the inside or the outside. Does not matter where. I'm going to end up choosing, let's do 2, 2. Let's choose that point right there. 2, 2. So this would be 2 is less than negative absolute value of 3 times 2. Close absolute value. Is 2 less than negative 3 times 2 is 6, -6? No. So this point 2, 2 is not a solution. So what we're going to do is we're going to shade inside the absolute value instead of being shaded outside. Only the stuff inside. Let's do the other one. The other inequality is linear, so that's nice. We have a point which is at 4. So this is our point there. Let me go ahead and get rid of this extra point. We have a point at 4. Slope is 1/2, so we rise by 1, run by 2, rise by 1, run by 2. Plugging this in. Let me actually make that a straight line. We have this as our graph. Make it extend as far as we possibly can. It's going to be another dashed line because no equal. So dash, dash, dash it all the way across. Put arrows. And let's figure out where we need a shade. Pick 2 points. We can choose 0, 0 because 0, 0 is not on our line we're working on right now. So let's choose 0, 0. Is 0 bigger than 0 plus 4? Well, 0 is not bigger than 4. So we have to shade the opposite direction since 0, 0 is not in the solution set. So our shaded region would be on this side. This is where we are going to end up shading for our answers. Now time to actually figure out what the answer is. Wait, there's no overlap. These areas that are shaded do not overlap each other. So there is actually no solution. The answer to this question is there is no solution. Yes, we graphed it to see if there was a solution, but there's not one because there's no overlap in the areas. Let's look at this one. Another example. Another example with absolute value. It's just so that we get used to the absolute values. We know it's negative on the outside, so that we know that this is going to be facing downwards. Let's figure out where this vertex is going to be. It's a +2 on the outside, so we are going to be going up by 2. It's a minus by 3 on the inside, so we're actually going to be going to the right by 3. So our vertex is going to be at 3, 2. This is a point at which it's going to be rising, it's going to hit, and then it's going to come back down because this is a negative one. Let's pick 2 points. 2 easy points right around that section. Let's choose 2 and let's choose 4. Okay, 2 and 4 are right beside. So let's do 2 and 4. So if we do this, this would be our table. We have X, we have Y. We're going to do 2. We are going to do 4. We already have 3 is at 3, 2. So if it's 2, we have negative absolute value of 2 minus 3, close absolute value, plus 2, which gives us negative absolute value of negative 1, plus 2. This is going to be negative 1 plus 2, which gives us 1. And if our work checks out, we could plug in that 4 and get the same result. So we would end up with 2, 1, and 4, 1. Also, notice there's not any multiplications in this one. Slope is a nice positive 1 slope and a nice negative 1 slope. It works out nicely for that. So that is how we do that. Let's check to make sure that it's either solid or dashed. It is dashed because there is no equal to on that. So this is going to be a dashed line. So let's make this dashed. Finish dashing this. We have to figure out which side it's going to be shaded on. Notice 0, 0 is not a point in this, so let's just choose 0, 0. 0, 0 is the easiest one in general. So if we choose 0, 0, this would be 0 less than negative absolute value of negative 3 plus 2, which gives us 0 is less than 3, negative 3 plus 2. So 0 less than negative 1. Well, no, it's not less than negative 1, so we are going to shade on the inside of this. So this is, if we were solving just that one inequality, that would be the solution to it. But let's see if there's any overlap with the other one. The other one is a nice equation because it's linear. We are at plus 5, so that's a y-intercept. We are having a negative slope, so we are going to be going down 1 over 1, down 1 over 1. Interesting that it just nicely overlays that right there. And let's figure out where we shade. 0, 0 is not on here, so let's choose 0, 0. 0 bigger than or equal to 0 plus 5. That's not true, so we are going to end up shading this way. The opposite direction. Lastly, let's figure out if there's any overlap. Well, these two shaded regions don't overlap, at least don't appear to overlap. Let's check the boundaries. Because the boundaries are the lines. The boundaries are the area that says it shall not pass. The boundary for our linear equation, the negative x plus 5, is solid, meaning that that is part of the solution set. The boundary of the other one, the absolute value, is dashed. So that line is not part of the solution set. So we have one that's solid, one that's dashed. There's no overlap. So this is another example of there is no solution. There's no overlap with this. Let's go ahead and look at another one. By the way, vertex is the areas in which these lines cross. The boundary is the line that says it shall not pass. Okay, that is the difference between those. Boundary says you should not pass. The other ones is where the lines cross. So we have this word problem. Jordan has up to 10 hours to train this week. And we'll spend 2 hours on strength work. That needs to be worked on, that sentence. Jordan walks between 4 and 8 hours. He works between 4 and 8 hours. That is a bad sentence. He works between 4 and 8 hours running and between 1 to 6 hours cycling. Woo! We are going to get through this. So we are going to set up a system of inequalities. We know that he wants to work at least 10 hours. But 2 of them is already spent. So instead of saying 10 hours, let's say he needs at most 8. One of these we're going to say is x. The other one we're going to say is y. We're going to call the running, that's going to be x. The cycling is going to be our y value. So if we add our running and cycling hours together, it should be those 8 hours because we already had the 2 hours taken care of. Another thing is, we know that he wants to be running between 4 and 8 hours for that week. So between 4 and 8, that means 4 is less than the running hours, which is going to be less than or equal to the 8 hours. It's somewhere between there. We don't know where. It could be the 4 hours, it could be the 8 hours, or somewhere between. Another thing that we know is that the cycling hours is between 1 and 6. It could be 1, it could be 6, or somewhere in between. So we have just created ourselves a system of inequalities. Okay, well, let's figure out how to graph this. The x plus y equals 8, that one's not too bad. Plug in 0 for x, we get 8. Plug in 0 for y, we get 8 for the y. And, plug in 0 for y, we get 8 for the x. So this first one is going to be like this. By the way, we cannot have a negative amount of hours, so it would not make sense to go any farther. Also, quick question, is it going to be solid or dashed? Well, it says that he has up to this amount, so it could equal the 8. So we actually want to put that line underneath, which means that this would be a solid line. Okay, well, let's figure out if we have some solutions. Let's assume that he did not do any. Let's say he had, let's go with, let's say 5, 2. Let's say 5, 2. Let's say we are at this point right there. 5, 2. 5 plus 2, is that less than or equal to 8? Well, 7 is less than or equal to 8, so that checks out. So we have one shaded region, which is going to be down here. This is our first shaded region. Next thing that we need to do, let me just get rid of that pink dot. I'm going to reshade, just so we have the stuff that's important to us. Between 4 and 8, the x is bigger than 4. X is less than 8. If you see just an x and no y value, this is going to end up to be a vertical line. Okay? Vertical line just at 4. And another vertical line just at 8. And we're just going to look at the area between. So let's shade the area that's between this. So we have a little bit of overlap. Not much, but we have a little bit happening. By the way, just some vertex to point out. We have a vertex here. We have a vertex here. That's whenever they cross. Let's look at the y values. Y value is horizontal. So we're going to have a y value at 1. And we're going to have a y value at 6. Let's shade this. So between here and here. Just between there. So the only spot that they all have in common, because we're comparing all three of these, the only spot that they all have in common is right in this little triangle here. That's the spot that they all have in common. Nowhere else. So the solution to this is only within that one triangle. Only within that one space. So in order for this to work, we would have just the triangle as our answer. Okay, so make sure that whenever you're doing this on your homework, you specify that this is my answer spot. So we can kind of just outline the triangle and kind of indicate that that is where these solutions lie. Vertex. We have vertex right here. Let me actually use a different color. Let me use green. Vertex there, vertex here, and vertex here. These are the points which the lines cross.